Newton's third law of motion. In Newton's second law, or according to the second law, force is necessary to cause the acceleration. That means if this is a body, suppose I name this body as A, it is moving with velocity v1. So to change its velocity, I need some force, external force, and due to this force the body may accelerate or decelerate and change its velocity to v2. Now the question arises, what is the source of force? According to Newton, the source of force is another body. That means if I want to change the velocity of this object A or body A, I may have to push it with my hand, or I have to use some source like another body which will push the body A. So in that situation, this body A is pushed with another body or may some another source B, and it is pushing with some force F. But here Newton defines the Newton's his third law. He says that forces always occurs in pairs. If there is a force from B to A, there must be a force from A to B, the counter force. And it is the simultaneous one. The moment at which the force B to A is acting, at the same time the force from A to B is also acting on the body B. More precisely, if I draw this body separately, like this, the moment at which A is acted by the force from B, this is A body, this is B, and this is the force acting from B to A, we write it as FBA. At the same time, the another counter force is acting on body B, and this force is from A to B. That is, it is the counter force from the A body from the B. So according to Newton, there is a counter force, or what he called as the reaction to the action FB to A. So this is nothing but the Newton's third law. For every action, this is the action, there is equivalent, opposite and simultaneous reaction. But the thing that we have to note, action and reactions both are acting on the different body. Here FBA, if it is a action force which is required to change the velocity of the body A, the moment at which F is acting, at the same moment FBA is also acting, which is from A to B. We can experience this. If you hit a ball with your leg, ball may move away, football will move away, but at the same time our legs also feel some hurt, or we can say push from the ball. There are many other situations. If earth is attracting any other body towards it, in fact that earth is also pulled by that small object, though we cannot experience this because the mass of the earth is too large. So this is the another situation you can experience the action and reaction forces. When you walk on the road, when you push on the road is also pushing you, due to that you are moving ahead. So these are some examples. A spring, if you compress the spring, your hands also experience some push from the spring. So if you are pushing, you also experience a push from a spring. a book kept on the table. It is applied some force on the table. Table is also applying the some force which is called a normal force to on the book. Thus, these are the many examples which states that for every action force there is a simultaneous reaction force. The some points related with Newton's third law, we should note it. The first point is that the action and reaction forces are not applied after some time. They act at the same moment. Means you cannot imagine first action force has applied, after some time the reaction force is being applied. So it is a wrong visualization of the Newton's third law. Both the forces acts in opposite direction at the same moment and on the different bodies. And one more thing, uh, suppose if AB is acting on the body B, the acceleration of body may be different from the acceleration of body A. That means suppose this body B is applying the force on A, it may also get accelerated, but the quantity of acceleration and direction of acceleration will be different from the acceleration of body A.